Hi, welcome to my presentation about the Poultry Market Roof. I will give a sort of a brief overview about the project, description of the geometry, the assessment and analysis, and some summary of the shell behaviour and concluding remark. The project is located in London, near Fountain Station, in the old Smithfield Market, which has been bought by a museum to relocate its uses into the building. Part of it is the Poultry Market Roof, which is shown in here. A couple of pictures showing the roof from the outside and inside. In terms of geometry, the roof is about 70 by 40 meter in dimensions, with a rise of 9 meters at the center. The roof shell is about 75 millimeters thick in the center and 100 millimeters thick in support. It is supported by 4 wedge beams, which in turn are supported by 4 columns, and there's an overhang slab picked up by incline columns. On plan, this is how the roof looks like. It was originally designed by Over in the late 50s and then executed by Sir Robert McAlpine. We've been fortunate to have some reinforcement drawings as well to feed into the analysis and assessment of the roof. In terms of the approach, we looked at it from using the original design and geometrical parameters, and then in the first stage and the second stage we then looked also at the results of a fabric survey, and particular checks we've carried out is determining the buckling factor for the dome shell and checking local failure of concrete. To determine the sort of current condition of a roof, we've carried out an extensive fabric survey studies to determine Young's modulus, concrete strength, pre-stressing level in the roof. We've also done a point cloud survey to see if there have been any large deformation of the roof surface, which doesn't appear to be the case. It is pretty much in its sort of original intended position. And on the right hand side you can see locations where we've carried out pre-stressing samples, pre-stressing samples of the tendons. As I said, it's the intention to replace the existing roof. Here are the sort of build-ups of the sort of original design, refurbished build-ups, and the proposed one. The sort of proposed build-ups will be below the original design allowances. It should be mentioned that the original, the refurb roof loads are higher compared to the original design allowances. In terms of the procedure, as I said, we had 2 stages determining buckling factor and checking local failure. So we've done this for base model using the original design parameters and upper lower bound models, looking at using the 20% increase and decrease in material parameters from the best estimates from the fabric surveys. So that resulted in analysis of 28 models for calculation of the buckling factors, which were then also used to check the local failure of the concrete. Here's sort of a summary of the determination of the concrete strengths, mean strengths, and the Young's modulus based on various fabric surveys, and the pre-stressing levels determined on site due to site testing, compared to the ultimate pre-stress loads. So for models, so during the analysis we use the construction stage history to model the sort of construction and the pre-stressing as described in the literature. There are a couple of ICE documents which describe the construction and the design of the roof. And then also considered creep and shrinkage and the roof replacement in the 1980s to basically determine the sort of loss of a pre-stress within the roof levels, and also the estimate deformations of a roof. In terms of the sort of outcome of the analysis, the sort of buckling pretty much in all scenarios happens in the first corners. So the fourth buckling modes are the first corners, and then the further buckling modes sort of start off at the corners and are of larger extent. In terms of the results of the buckling factors, the range for the model between 7.5 and 11, and for the upper lower bound model between 5 and 10. So that should be noted that the lower ones are using with 20% stiffness reductions compared to the best estimates. Overall, we achieve a buckling factor of 8 using the best estimates and upper bound material properties. And in terms of behaviour, the Young's model has biggest influence on buckling factor, and pre-stress and have very little influence on it. In terms of strength, we've determined the factor of safety of total load over proposed load by doing sort of like in exclamation mark a pushover analysis. It appears for the best estimate material properties that the shell achieves sort of adequate factors of safety to satisfy modern codes. In summary, the sort of concrete shells are very efficient structures which provide opportunities for like a reuse of the buildings, in particular in the current environment where we should avoid demolishing buildings. We overall, using best estimate material parameters, we achieve buckling factors and local failure to modern code standards. So like in terms of further work, we need to do further studies to consider the unloading and reloading during the replacement of a load, because it's asymmetric. And then final comment on the recommendations for reinforced concrete shells. It seems a bit outdated considering it was written in the 1980s and that codes and analysis methods have moved on. Thank you very much for your attention.